In this video, you will learn about geometric mean. Geometric mean is a number between any two given terms of a geometric sequence. For example, in the sequence below, we have 1, 2, 4, 8, 16, 32. The numbers 1 and 32 are what we call geometric extremes, while 2, 4, 8, and 16 are the geometric means. Later, you will be taught on how to solve for the following items about geometric means. Okay, so for the first item, insert two geometric means between 5 and 135. Okay, we will start with our solution with the given values. So we have 5 and 135. Now, since we're going to insert two geometric means, we will write two blanks in between them. Inserting two geometric means makes 5 to be the first term, our a sub 2 and a sub 3 are unknown, and then our 135 is a sub 4 or the fourth term. We will solve for the common ratio first. So to solve for the common ratio or r, we will make use of our formula for the nth term of geometric sequence and express our a sub 4 or the fourth term as a sub n. So we have here 135 is equal to our first term, which is 5. R is unknown, so just write r, raised to the power of n, which is 4, and then minus 1. Next would be just copy the rest and then simplify the exponent first. So we have 4 minus 1 is just 3. And then we are going to divide both sides by 5 to solve for r cubed. So we have first, for 135 divided by 5 is just 27. And then 5 divided by 5 is just 1. So what's left is r cubed. Next would be, let us reverse this. 27 is equal to r cubed is just the same as r cubed, which is equal to 27. Next would be to solve for r, let us find the cube root of r cubed and the cube root of 27. Now the question is, what is the cube root of 27? Since the index here is 3, then what is a number that when multiplied to itself 3 times will result to 27? That is just 3, right? Because 3 times 3 is 9, times 3 is 27. Therefore, the cube root of 27 is just 3. So, 3 here now is a value of r or common ratio. We will multiply that value to the first term to obtain the second term. So, 5 times 3 is just 15. Next, times another 3 to obtain the third term. So, 15 times 3 is just 45. So, basically, that's just how you solve for the value of r to get the geometric means. Hence, the geometric means between 5 and 135 are 15 and 45. For the second item, find 3 geometric means between negative 2 and negative 162. For our solution, we'll just write down our values or given values. So we have negative 2 and negative 162, and then the 3 geometric means that are known. So we have the first term, or a sub 1, is negative 2. The second, the third, and the fourth term are unknown. And then, we have negative 162 as our fifth term. So, we will express our fifth term as a sub n. Now, we have negative 162, which is equal to our first term, which is negative 2, multiplied to r raised to the power of n minus 1. So, our n here is 5. Minus 1. Next, simplify the exponent. So we have 5 minus 1 is just 4. And then divide both sides by negative 2. So we have negative 162 divided by negative 2 is just 81. Negative 2 divided by negative 2 is just 1. What's left is r to the power of 4. Now let us simplify this one. Let us find the fourth root of r and the fourth root of 81 as well. What is the fourth root of 81? So the number that when multiplied to itself 4 times, that will result to 81 is just 3. Because 3 times 3 is 9, times 3 is 27, times 3 is 81. So the fourth root of 81 is 3. Now we have 3 as a value of our r, so we are going to multiply it from the first term to get the second term. We have these 3 values here as our geometric mean of -2 and -162. For our third example, some items are written this way: 8 blank 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 128. So it is clear that the geometric means that are known here are 3. So we'll just write here the given values. So our first term is 8, second, third, and fourth term is unknown, and then the fifth term is 128. The same as earlier, we will just express the fifth term as our nth term or a sub n using the formula for the nth term of geometric sequence. So we have here 128 is equal to our first term, which is 8, and then just copy r, raised to the power of rn, which is 5 minus 1. Then simplify the exponents. 5 minus 1 is just 4. To solve for r to the fourth, we'll divide both sides by 8. 128 divided by 8 is just 16. And 8 divided by 8 is just 1. So what's left is r to the power of 4. Next, find the fourth root of the both terms to solve for r. So what is that number that when multiplied by itself 4 times will result to 16? Since our index is 4. So that number is just 2, right? Because 2 times 2 is 4, times 2 is 8, and times 2 is 16. So our fourth root of 16 is just 2. That is also the value of our r. Now, use r to multiply to our first term to get the second term. So 8 times 2 is 16. Multiply it to our second term to get the value of our third term. So 16 times 2 is 32. Times another 2 to get our fourth term, that is 64. Now, hence, the geometric means between 8 and 128 are 16, 32, and 64.